Hello again. This is Jeremy. Today I wanted to take a slightly different approach. Instead of doing the math, I wanted to introduce you to a resource that I think is critical if you want to teach cognitively guided instruction or CGI, particularly when you're thinking about teaching number stories. This document that I'm going to share with you today is largely based on the book Children's Mathematics, Cognitively Guided Instruction by Carpenter et al. And this particular document was made as a simplification for some of the strategies that they talk about in the book, as well as the problem types or story problems that are associated with those strategies. It was made by Dr. Stephanie Smith and her husband, Dr. Marvin E. Smith. And I've been using it for years. It's a very helpful document. I want to introduce it to you and tell you how it can be used for understanding cognitively guided instruction, but also understanding how to plan and even interpret the and elicit thinking for how students are solving problems. So I'll keep this short because our other videos will go deeper into each problem type, as well as the strategies that you're likely to see with those problem types. But behind me, you'll see this chart, right? And this chart represents all of the arithmetic problem types that exist in context or in story form. So basically, what we're seeing here is across the four operations, these are the kind of scenarios in which addition, subtraction, multiplication, and division can play out with whole numbers. This also applies to fractions and decimals, but the focus here is on whole numbers. So what you'll see here, organized very helpfully by color, as well as by Roman numeral, is you'll see four different groups. So let's start first with the blue area, right? So you'll see join result unknown, uh, separate result unknown, and part whole unknown. And what you'll notice is that the commonality that these all have is that the result or the total is the unknown. So you'll see that box, right, which could be represented by an X, right, or any variable, is the thing that's not known. What you'll notice about these problem types is that they're very simple from a narrative structure, right? So let's look at that first one. Leon had 5 colored pencils. His mother gave him 9 more. How many colored pencils does Leon have now, right? So he has something is joined to that quantity, and then you're trying to find the result. Now, you'll see that the separate result unknown problem that's right next to it is very similar, right? Is that you had something, you lost some of it, and then you're trying to figure out how much you had left. And then the part whole relationship is very similar, right? There's less action, right, in the part whole relationship, but still you're trying to find a total of two given parts. If you skip down, and this might be surprising to some folks, if you skip down to the green, that's Roman numeral 2. That is, the way that the Roman numerals work here is that from a child's perspective, the lower the Roman numeral, the easier the story is to understand. So you'll see for 2, even though those are multiplication and division problems, as well as a comparison difference unknown problem, the structures of the problems and the stories themselves are actually easy for kids to understand, or second easiest to understand. So compare difference unknown. Willie has 15 crayons. Lucy has 7 crayons. How many more crayons does Willie have? Right? Now, that actually can be a tricky problem for younger kids, including kindergartners. But they do understand typically that two quantities are being compared, and what you're trying to figure out is the difference between the two quantities, right? How many more or how many less does someone have than the other person, right? Now, across the bottom, you'll see those are multiplication and division problems. We can talk a little bit later in other videos about the difference between partitive and measurement division. But briefly, kids understand that there can be multiple groups of something, right? And that those groups can be divided up in different ways, right? So from a multiplication perspective, you'll see something simple like 7 boxes of cupcakes, 4 cupcakes in each box. How many do you find all together, right? Or separating, right? Measuring. Actually knowing how much is the total and how much is in each group and measuring out to find out the number of groups, or the opposite, right? Which is part of the division, knowing the total, knowing the number of groups, and figuring out how many grows in each group. That's partitive division. Moving up in difficulty, even though they might seem like more simple, straightforward problems from a math standpoint, are the change or part unknown problems. So you'll see in yellow, that's Roman numeral 3. Kevin has $7. Well, let's look at the join change unknown problem at the top. Kevin has $7. How many more dollars? Because Kevin need to have $11 altogether. You're missing the middle variable, right? You know what you started with. You don't know what the change is, but you do know the total that you arrived at. Or in the case of the change unknown or the part unknown, you very similarly don't know what the change in the middle is or what a missing part is. And then lastly, at the most difficult level, Roman numeral 4 in the pink here, you'll see that the start is unknown um, for the join start unknown problem and the separate start unknown problem that are right above me. You don't know how many you started with. So Eve had some pebbles in her pocket. She found 8 more and then put them in her pocket. Now she has 14. So the student actually has to interpret this idea that they had something, but it's an unknown to start with, which is almost the opposite of that join result unknown problem that we looked at the very beginning, right? Now, if you look right here, oh, excuse me, over here, those are the two other types of comparison problems, right? Where the comparison quantity is unknown, or the referent is unknown. So like before, when we were talking about the difference being unknown, which is the literally difference, right, in quantity between those, there's also the comparison quantity and the referent, right? And you'll see by reading through those stories why those are a little bit more difficult than the others. So these are the 15 different types of arithmetic problems that exist, right? This is all the places in simple whole number, addition, subtraction, multiplication, and division, where the variables can be in different places, but they're all put in story form, right? Because CGI is all about understanding how students think, right? So that is a sort of rundown here. These are really helpful for understanding how students will experience the difference in the way that problems are worded or where the unknowns happen in a story, or even if there's any movement or action in a story at all. So if you look across this row up here, let's see if I can get it right. This row here, right, with the comparison problems, there's actually nothing happening. It's all analysis of a situation, right, where the kid actually has to almost like make sense of it mathematically. Instead of like in a join result unknown problem or a join change unknown problem, where there's a narrative where something's happening, being lost, being gained, or you don't know what's being lost or gained, and you have to find that out. Super helpful to understand how students will approach and interpret these, right? And this is why we focus on comprehension and asking students comprehension questions so that we understand if they're thinking about the problems algebraically, meaning they know what's happening, right? They know what they know, they're aware of what they know in the problem, and then they're aware of what they're trying to figure out, right? So that's this document. It'll help you understand the problems algebraically also as a teacher when you're planning. And then let's look at the companion document, right? That's actually typically on the back side of this, right? So these are the strategies that are associated. I'm going to move my head a little bit so you can see that. These are the strategies that are associated with different problem types. So if you look at it, and you'll see in our planning video, right, our anticipatory planning video, as well as all the different problem type videos that we have, that we go into depth into what each of these strategies look like. But for now, what I wanted to introduce you to is the why this document is helpful and how it associates with the previous chart that we were just looking at with problem types. All right. So what you'll see here on the left is the direct modeling level, right? Which is the simplest way for students to solve a problem. That's up there in blue. Direct modeling literally means that students are using a manipulative physically and every quantity is represented. Now, they can actually direct model on paper, but it still means that every quantity has to be represented. So if we're joining 7 and 5, or let's say joining 15 and 6, right? You can't just do you can't just do a 10 stick and then 5 ones. Um, that the every quantity would need to be represented for it to be direct modeling. All right. So let's talk a little bit about the way that the strategies work when you go across, right? So there's direct modeling strategies, where meaning every quantity is represented. But then you'll also see joining, separating, and comparing strategies. So joining all, joining to, and trial and error joining are strategies that are related to joining problems. So if we toggle back really quick, you'll see that there's a joining section up here across the top. Join result unknown, join change unknown, join start unknown, right? So those strategies are typically associated with those problem types, right? Separating strategies are associated with the separating problem types, right? Separate result unknown, separate change unknown, separate start unknown. So you'll see that those separating strategies in the middle column here are associated with that. And then comparison strategies are on the right-hand side, right? So there's for example, matching, right? Again, we'll talk about that in an upcoming video on the comparison problem types. But then if you move down, counting strategies mean that there are not all quantities represented. So kids might be using a number line, um, their actual fingers, or counting strategies in their heads, but not all quantities are represented. It makes it a little bit more sophisticated than a direct modeling strategy because they aren't relying on that. It's a step towards abstraction, right? And you'll see in the same way, the joining strategies are in that far left-hand column, the separating strategies in the center, and comparing strategies on the right, right? Now, as you go back down, even though that yellow bar only represents a small part of this, the base 10 strategies and inventive algorithms are actually a huge part of cognitively guided instruction. That's where student thinking tends to be the most sophisticated and complex. But an invented algorithm is simply students figuring out a way to add, subtract, multiply, or divide numbers using base 10 strategies, or algorithms that will work every single time, right? So for example, one student might understand that if they're joining two quantities, they can separate those quantities into tens and ones and add the tens and then add the ones and then add everything together, and it'll always give them the appropriate total, right? No matter how many add-ins, right? So that's one example of an invented algorithm, that's based on base 10. And then last but not least, down at the bottom, you'll see that there are number facts-based strategies, including deriving facts as well as recalling facts. Now, recalling facts doesn't sound so sophisticated, but it does come after repeated exposure and fluency of a particular problem type. So, for example, it might not occur to a first grader that even though they've added 7 and 3 100 different times, it might not occur to them that they actually are always going to get the same total, right? But once a kid does understand that, they have arrived at a place of fluency and memorization so that they can recall the fact. Now, a derived fact is students using relational thinking to be able to almost use heuristics to know something that's related to a fact that they know. So, for example, if a student knows that 7 plus 3 is 10, they know that 7 plus 4 is 11 because 4 is one more than 3. Therefore, 7 plus 4 must be one more than 10, right? So the total is 11. That's a derived fact, right? And then along this side, you'll see that there's this idea of flexible choice of strategies. Sometimes, even though certain strategies are a little bit less sophisticated than those down at the bottom, a flexible choice might be important. So if we take, for example, the problem of 1001 minus 999, an algorithm where you separate, right, the tens from the hundreds, right, from the ones, and subtract, or even using the standard algorithm, right, stacking, might seem like the most sophisticated way, whereas that's actually easiest to solve with a less sophisticated strategy such as counting, right? 1001, yeah, in your head, 1999, the answer is 2, right? So let me just preview the last page here. It's very similar to the document that we were just looking at, but it's associated just with multiplication and division. So if you look on the left-hand column, there's a multiplying strategies column, right? And then in each area, direct modeling, counting, base 10 strategies, and then number facts, you'll see that you increase in sophistication as you go down, but they're related to multiplication. So grouping, repeated addition, doubling, skip counting, etc., those are related to multiplication. Whereas measuring strategies are related to measurement division, and partitioning strategies are related to partitive division. So, in summary, this document allows you to understand the 15 different types of arithmetic problems in mathematics, which is the bulk of K to 5 math, right? It helps you understand them from an algebraic standpoint by showing you not just where the unknowns lie in those problems, but also how children interpret them and what level of difficulty they have when they're approaching problems like this, right? Then on the following page, right, on the flip side of this document, you'll see that there are a set of common strategies when kids are allowed to solve the problems on their own in a number stories classroom or a CGI classroom that they typically use to solve them in increasing levels of sophistication for joining, separating, comparing, multiplying, and dividing scenarios. I hope that's helpful. Stay tuned for some more videos that explore what these strategies look like in action. And if you want to check out more about what these strategies look like, check out the Cognitively Guided Instruction book, Children's Mathematics, because there are links to videos of students solving these problems and sort of showing how they figure those things out and what their thinking sounds like, even what their use of manipulatives or drawings looks like to be able to solve these problems. Those videos are all linked at the beginning of the book. Thanks so much and take care.